My name is Robin Shoemaker. I work in the lab of Dr. Lisa Cassis at the University of Kentucky, and I'm a postdoctoral scholar. No one in my family is interested in science, and I never really knew that I wanted to be a scientist. I thought that I wanted to be a lawyer like my dad. But then I noticed that I had kind of a natural curiosity or inquisitiveness for the natural world or the physical world around me. I lived in a small town in New Mexico. The desert actually is beautiful, and there's a lot to appreciate about the natural world there. I did my bachelor's degree at the University of Colorado in chemistry, and I found that I was most drawn to some of the biological sciences, and I was really fascinated with the way that the body works and the way that therapeutics work, and all kinds of things like household products, and the chemistry behind that really drew me in, and I started considering looking into science as a career. When I was an undergraduate, I focused my work in analytical chemistry, and I had a really great mentor, and I did a really cool project, but I just didn't think that I liked it enough to sustain all the way through graduate school. And so I came to the University of Kentucky, and I met Lisa Cassis, my mentor. She was doing research in obesity and related diseases like hypertension and diabetes. She suggested that I could focus my interest in nutrition on some of those problems, since they're really epidemics in our society right now. I did my PhD work on the role of the renin-angiotensin system, which is primarily a system that's involved in regulating blood pressure and fluid homeostasis. And there's actually a lot of evidence that the renin-angiotensin system can influence the development of type 2 diabetes. So a lot of clinical trials have shown that drugs that inhibit the system for treatment in high blood pressure have also shown to be positive against delaying the development of diabetes. And so if we can learn the mechanisms by which inhibiting the renin-angiotensin system can impact pancreatic beta cell function, then that could open up a new line of treatment for people who have hypertension, obesity, and type 2 diabetes. So I've been working in this lab for about 5 years. And one thing I really like about this lab is that even though we all have our own projects and we work fairly autonomously, there's a collaborative spirit that really helps each individual engage with others to help further their interests of their own project. And so when I came to this lab, I was kind of unsure of myself as a scientist, and the support that I got has really helped me become successful as a scientist. And so it's really a mixture of working at the bench and analyzing samples that I've gathered, to sitting at my desk reading and writing. So a day here can be pretty varied. So the most challenging thing that I've found in this career path is learning new techniques or methods. It's also the most fulfilling because I've learned so much about what I'm capable of as a scientist. And when I learn a method completely from scratch, it gives me a whole new confidence in myself. The most exciting aspect of my work is the ability to look at molecules or proteins and implicate them in some disease process that no one else has really looked at before, and the chance to target that therapeutically and make a difference in treating people who have diseases like type 2 diabetes. It's really a compelling reason to go forward every day.